Precalculus. This video is on sequences and series for the lesson that we're going to be doing this coming week. Sequences and series. So I'm going to begin by giving you some notation. What you see here is basically braced notation. Inside there's a sub n, and when you see a brace set like this, it indicates a set. And when it's a variable expression, it is a closed set notation for what you would get if you listed out as a roster everything that's inside. So most of the time sequences begin with n equals 1 because we sequence things by counting, by saying 1, 2, 3, 4. And as a sequence, the 1, 2, 3, 4, etc., which used to be called cardinal values, get pronounced first, second, third, fourth, fifth, until you reach whatever n is, and that's the nth term. And that would be the ordinal values. So this is the closed or braced notation for the sequence that, when indicated individually, is expressed like this list. The 3 dots is called an ellipsis, which indicates that the pattern will continue until you reach whatever value n is. Another way to read this is as a functional notation. F of n will give you the nth term, a sub n. Some other expressions we need to know. It's called factorial, F-A-C-T-O-R-I-A-L. It's not an exclamation point such as to indicate that somebody's shouting the letter n at you. You simply read it n factorial. And what it means is you start with the number n and then begin multiplying by it by each number that precedes it by 1. So in other words, if this were a 3 factorial would equal 3 times 3 minus 1, which is 2, and then times 3 minus 2, which is 1. And we always stop when we reach 1. We don't go any further than that. 2 special definitions. 1 factorial equals 1 and 0 factorial equals 1. You may see that. So 3 factorial being 3 times 2 times 1, that's 6. 5 factorial would equal 5 times 4 times 3 times 2 times 1. Multiply that out, that's 120. Here's an example of a sequence. We're going to find the first 5 terms starting with n equals 1, for the given sequence whose nth term, a sub n, is to be found by setting a sub n equal to n factorial divided by n. I'm going to use function notation so we can get comfortable with it. We're going to find f of 1, f of 2, f of 3, f of 4, and f of 5, so that we will have found a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. F of 1 equals a sub 1 equals, since n is 1, we plug in 1 here and do 1 factorial over 1. By definition, 1 factorial is 1. 1 over 1 is 1. So the first term, a sub 1, is 1. F of 2 will give me a sub 2, which is going to be 2 factorial over 2. And 2 factorial is 2 times 1. And 2 times 1 over 2 equals 1. F of 3 will give me the third term, a sub 3. For this given sequence, a sub 3 is equal to 3 factorial over 3. 3 factorial over 3 equals 3 times 2 times 1 over 3. The 3's cancel. 2 times 1 equals 2. So the third term is 2. The fourth term, f of 4, is found, which is equal to a sub 4. Using this notation for this particular sequence, that will equal 4 factorial over 4. 4 factorial is equal to 4 times 3 times 2 times 1 over 4. The 4's cancel, leaving 3 times 2 times 1, which is 6. The fourth term is 6. The fifth term, f of 5 equals a sub 5 equals 5 factorial over 5 equals 5 times 4 times 3 times 2 times 1 all over 5. The 5's cancel, leaving 4 times 3 times 2 times 1, which is 24.